You're welcome. Okay, okay. You're welcome to ninth class. Please like, share, and subscribe. I'll be very grateful. Okay, I will be looking at array analysis, basic properties of array number system. We are going to do a lot tonight. If you don't understand, please don't forget to drop your question in the comment section. I'll get back to you. Is that clear? Okay, yeah. Let's uh, let's look forward to understand the meaning of real number system. The word real number system is also known as complete ordered field, and we shall discuss the following properties. 1. Algebraic properties of real number system. Yeah, of real number system. This is also called the field properties in abstract algebra. Amen. A real number, that is algebraic properties of real number system, is also known as the field property, also known as this is also called the field properties in abstract algebra. Is that clear? So it means algebraic properties of real number system is also known as what? Field properties in abstract algebra. And as long as this is concerned, we are going to consider some operations. But let us try to know the notation of real numbers. Is that clear? When we have this is known as what? Real number. So anywhere you see something of this form, it is always referred as what? A real number. Is that clear? Yeah. Some of you want to, the way it is, you want to say this is arrow. Is that clear? This is not arrow. This is how we can write real number. Short form. Is that clear? So take notes. Are you following? So that is that. So let's move further to consider the operations, the binary operations. For example, we can consider addition and multiplication. Is that clear? So let's move further to consider some few examples. Amen. Okay. Addition properties. One of the binary operations we want to consider is addition properties and multiplication properties. Is that clear? Let's consider one under algebraic properties of real number system. Addition properties. Addition properties. Amen. Okay. Yeah. Before one can go deeply or deep to know abstract algebra, you must take note of these properties. Addition and multiplication properties, as well as what? Identity properties. Is that clear? So I will move gradually, step by step. I'm not going to rush you. But in case you have any question, please don't hesitate to ask. In addition properties, addition properties are talking about commutative law. Let's exhibit the commutative law under addition properties. Is that clear? Commutative law, that is by commutative law. Amen. Yes, before I write anything, let me just briefly explain what commutative law is all about. It's something we have been applying in real life, but unknown to us. But mathematicians, we all know that we apply commutative law. Okay, just look at the board very well. Let us have variables. Look at this variable. We have A and we have B. Amen. You can now see that A is on the left hand side, true or false. Then while B is by the right, true or false. So now, if we want to apply commutative law here, I'm just trying to explain it. Is that clear? If we want to apply commutative law here, it implies that this one by the right will now come to the left, then this one by the left will now come to the right. So looking at this, you can now see that here we exhibited what? Commutative law. So take note of it. Sometimes in real life, when you and your girlfriend, you are working together, sometimes your girlfriend might be at your left hand side, true or false. But all of a sudden, she will now move to what? To the right hand side. It means you are applying commutative law in real life. Take note. Is that clear? Any question? Do you have any question before we proceed? So please take notes. Is that clear? Okay, so let's proceed. Let us proceed to exhibit addition properties by commutative law. Is that clear? So one, the addition property A says that if we have A plus B, as long as real number is consigned, this is the same thing as B plus A. Therefore, for all in A, comma B contained in real number. Take note. Is that clear? So this is one of the properties under addition. Take notes. Any question? Do you have any question? Do you have any question? So far, so good. Then let's consider another one. B. Here, if we have A plus open brackets, A plus B close bracket plus C, it means this is the same thing as what? A plus open bracket B plus C. For all in A, comma B contained in real number. So take note. Is that clear? Do you have any question? Look at the board very well. Do you have any question? So before one can be able to prove any of the theorems, at least you must take note of all these properties. Is that clear? This one is commutative. Then this one is associative. Yeah, associative. This is associative law. Under associative law. Okay, let me just clean it. Let me clean it. Right? And write it under associative law. I'm going to explain associative law in real life. B, which is A plus B close bracket plus C is equals to what? A plus open bracket B plus C for all in A, comma B and C contained in a real number. Are you following? Okay, yeah. Let me explain associative law. Yeah. Here we are able to represent it in algebraic form, mathematically, two of us. So now in real life, we do apply or make use of associative law, like the commutative law I have explained earlier. You know, associative law, do you know when you make use of associative law? Okay, let's look at it this way. In real life, sorry to mention, those of us that have one, as long as you have more than 2 girlfriends or boyfriends, you are applying associative law, unknown to you, but that is mathematics. Yeah, in the real life, some big girls, they apply associative law. How? They will, date up to how many guys? One will be responsible for house rent, the other will be responsible for what? Recharging of airtime, the other will be responsible of clothing and the rest. So when you come across that kind of person, just know that that person is applying what? Associative law. But sometimes if you happen to say, please come and learn mathematics, those sort of people, they will tell you that mathematics is difficult. But they are the one applying the mathematics to get what they want, unknown to them. Yeah. So that is associative law. Any questions so far, please ask your question. I'll be glad to answer you. Any question? No question? No question? Okay, so let's proceed. Let us proceed further. Let us proceed further. Okay. So let us also consider the existence of zero law, that is C. Zero law, that is C here. Existence of zero law. Existence of zero law. Amen. Okay. Yeah. Let's look at it. If there exists an element, amen, an element 0 contained in real number, amen, such that amen, 0 plus what? A equals to what? A. Two of us. Look at the board very well. Look at the board very well. So you can now see that for all in A also contains in what? Real number. So, sometimes we play with numbers, two of us. Yeah, sometimes we play with numbers, as in, we want to say 0 plus 2. This is equals to 2, two of us. Yeah, so it means as it is, this is what? Existence of, zero law. Existence of zero law. So when you come across something of this form, note that there is existence of what? Zero law. Then at the end of the day, you are still going to get two of us, because 0 plus 2 is 2. Is that clear? Any question? Please, do you have any question? Ask. Do you have any question? Ask. Then, we also consider existence of negative elements. We also consider existence of negative elements. Is that clear? Can I clean the hub? I want to clean this up. Existence of negative elements. Amen? Okay. Yeah. Existence of negative elements. Is that clear? Okay. That is D, right? D. Existence of negative elements. Negative elements. Okay. Let's look at it. You know very well that these our arms. This is right, this is left, two of us. Yeah, it's true. But I want to tell you that, we always see this as what? Negative. Yeah. Generally, everybody know that this right hand side, this your right hand, is positive, two of us. Then anything left is what? Is negative, two of us. Yeah, that is how it is. So if there is existence of negative, it means at the end of the day, your result might be what? Equals to 0. Yeah. Okay, let's look at it this way. If we have minus A, then this minus A will now be plus A. You can now see that minus A plus A. What do you think will happen? It's going to be what? 0. Two of us. Because it's just like minus 1 plus 1 equals to what? 0. Two of us. So you can now see that the existence of negative element. Look at it here. Existence of negative element here is what? Is minus A, then plus A. Gives you what? 0. Look at the board very well. Can you see now? But note that this minus A is contained in real number. Take note. Any questions so far? Because take note of this. Anytime soon, we'll make use of this to prove some theorem. Is that clear? Take note. Any question? Do you have any question? Yes or no? No question. Okay. So That is that. I think you should take note of 1, 2, 3, 4, so that if you are asked to at least show the additional properties of uh, of algebraic real number system, algebraic properties of real number system. This is what you are going to write down. Is that clear? So take note, it's very important. Okay, so let's move further to consider multiplication property. Is that clear? Any question? No question. Can I clean? I can clean, right? Okay. I hope you are writing it down. It's very important because I will ask you to submit the note. Okay. Let us consider multiplication properties. Multiplication properties. Okay. That is 2, right? Multiplication property. We all know that multiplication property, multiplication is in this form, true or false? Yeah. Most especially those who are familiar with further mathematics, not just this, but as long as array analysis is concerned, or abstract algebra, we do make use of this. Yeah, let's consider the multiplication properties. I believe I have explained a little bit. If you, assuming if only you started the class with us. Okay, so let us exhibit multiplication properties. Is that clear? In multiplication properties, 1, it says or state that if we have A multiply B, it means this is the same thing as B multiply A for all in what? A comma B contained in real number. True or false? Which is what? You can now see that we still make use of what? Commutative law. Yeah. True or false? True or false? Please look at the board. It's true, right? Yeah. So this is one of the properties that one need to know. It's very important because we'll make use of all these properties to prove theorems. Is that clear? So if we have this A multiply B, it implies that this is the same thing as B multiply A for all in A comma B contained in real number. That is, here is a commutative law. We make use of commutative law and it's very important. Is that clear? Any question at this point? Do you have any question? Yes or no? No question? No question? It's okay. True. That is B. If we have A multiply B multiply C, amen? Yeah. Look at it. This is the same thing as A multiply B times C. Therefore, for all in A, B, C contained in real number. So when you look at this, algebraic equation, you can now see that associative law is applied here. True or false? It's true. So is associative. Any question, please? Do you have any question? Yes or no? Any question? No question. Okay. So we can proceed, right? Okay. Okay, let us exhibit identity law, that is C. If there exists an element, an element 1 contained in a real number from 0 such that 1.a is equals to what? A, true or false? Likewise, and a dot 1 is equals to a. True or false? So you can now see that this is existence of what? Identity. We are using existence of identity. Amen. No, in mathematics, when we say identity means 1. Or in some textbook, instead of existence of identity, you may see unit, or sometimes unity is same thing as what? 1. So as long as multiplication is concerned, we exhibit what? Identity, existence of identity. But in addition, we could not find an existence of what? Identity. Only 0, true or false? Because in addition, if we are to exhibit existence of identity, it means 1 plus A. It cannot give you A, true or false, and this is not equals to A. But rather, it's going to give you 1 plus A, isn't it? True or false? And this can never satisfy the argument, isn't it? Yeah. But if there exists existence of 0, it means 0 plus A is going to give us A. Likewise, A plus 0 is the same thing as A. But here, A plus 1, it cannot be equals to A. Rather, it will give you A plus what? 1. So it does not satisfy the axiom. So this cannot follow in addition property. But here we are talking about multiplication, true or false. So identity properties will definitely follow. Is that clear? So take note, because identity 1 times any variable is going to give you the variable, then that variable times 1 is still going to give you that variable. True or false? Amen? Any question? Please, if you have any question, drop it in the comment section. I'm waiting for your question, please. Any question? No question? No question? Then we are going to consider existence of reciprocals. Is that clear? Okay. Of Okay. You know, when we say reciprocal, some of you want to get confused. It's just all about division. Is that clear? If we have 1 all over A, is that clear? So just take note. So for each A not equals to, for each A not equals to 0, it means there exists, therefore there exists, we are speaking mathematics. This sign means, let me put it in brackets, there exists, amen, there exists 1 all over A contained in what? Real number. Is that clear? That is, if this is not equals to 0, the A, definitely the A cannot be equals to 0. That is what it's telling you. But if A equals to 0, you will now see that at the end of the day, here will now be 1 all over what? 0. And in mathematics, when we have 1 all over 0, this is what? Undefined. Amen? Yeah. This is undefined. Take note. That is why it stated earlier that for each A cannot be equals to what? 0. Take note. It means this implies that, from my own understanding, this implies that if this A cannot be equals to 0, if A cannot be equals to 0, this means that A can be what? 1. A can be what? 2. A can be like that, to N. True or false? So please take note. So far, so good. Let's proceed to consider this. Amen? Okay. So, yeah. Okay, where are we? Okay, for each A not equals to 0, there exists A all over what? 1 all over A contains in what? Real number. True or false? So this implies that if A is not equals to 0, it means such that A dot 1 all over A, amen, will give you what? Identity. True or false? True or false? And likewise, let's put it in brackets. Likewise, if we apply left, that is, 1 all over A dot what? A is equals to what? 1. So this is existence of what? Reciprocal law. Please take note. Any question, please? Take note of all these things. It's very important. Take note of all these things. It's very important. Very, very important. Any question? Oh. Yeah. That is that. Let's come to consider distributive law. Can I claim this right? Up. Distributive law. Amen. Distributive law. Distributive law. Properties or law. Anyone? Yeah. You know. I made a statement earlier using one girl friending 1, 2, 3. I think that process is applicable, most especially to distributive law. Please take note. Okay, let us have this. One of the properties. If we have A dot open bracket B plus C, amen? Yeah, amen. Yeah. Okay, so let's look up. Excuse me. Let's look up. I'm going to explain it in real life before we proceed further with the algebraic presentation. All right, okay. Now, let us apply it in real life. Amen. Let us have Esther in our midst. Esther. Amen. It means this is Esther. Yeah. This is Esther, right? Okay. Let us have Musa. This is Musa, right? Let us have John. This is John. Amen. Let us also have. Okay. Let us have who? Let us have Eddie. Yeah, I know Brother Eddie is here. Let us have Eddie. Eddie, yes. This is Esther, right? I'm trying to explain distributive law, and we are going to see it here mathematically. You can now see that Esther, that is Eri, will go and collect, but I don't know what Eri is going to collect from Esther. It's only them that know what they are collecting. Amen. Musa too will go and collect his own share. Then John too will go and collect his own share. But I don't know actually what John, Eri, and the rest are going to collect from Esther. I don't know. Yeah, but I'm just trying to explain this mathematics in a way that every one of you will understand. Amen. Amen. Okay. You can now see that Esther is given to who? Eri. Esther Esther is given to Musa, Esther is given to John. Don't be surprised that Esther will even exceed these three people, two of us. So you can now see that Esther is what? Distributing. But I don't know what she is distributing. Yeah. But if you see Esther around the environment, ask her what she is distributing. She will tell you better. Amen. Well, let's solve mathematics. Amen. Okay. So let me just show you mathematically how Esther distributes. This is Esther. Two of us. This is Esther. Yes. We have two variables here, B and C. Okay. We can now off Henry. Amen. Let us off Henry since we have two variables here. So this is Esther. This A is Esther. So look at how Esther wants to distribute. Now it means A dot B. Amen. A dot B. Can you see now? Plus A dot what? Open bracket. A dot C. Can you see the distribution? Only Esther is distributing to Musa, at the same time distributing to what? John. So it means when you see a friend in school, sometimes they call it what? Enjoyment. Two of us. They use what is called what? Distributive law to enjoy themselves. Two of us. It's true. Distributive law. So if you see a friend behaving that way, automatically she is applying distributive property or law. Is that clear? Are you following? Any question, please? Do you have any question? Yes or no? No question. So we can proceed, right? We can proceed, right? Then another one is if we have another one is 2, we have B plus C dot A. Can you see now? So here we have two elements, and these two elements want to share one property. That is Esther. Before it was Esther that was what? Trying to distribute. Now is these two that want to distribute. So see how these two elements will distribute now. So here we are going to have B dot what? A, then plus C dot, therefore for all in what? A, comma B, comma C contain a real number. Take notes. Is that clear? So I think the other one is if A and this are what? The other one is if U and B and B not equals to what? 0. It implies that this implies that U dot B equals to what? B, where or such that U is equals to what? 1. True or false? Yeah, take notes. Is that clear? Take notes. Oh, sorry. Oh, sorry. Sorry. So let's try to prove one theorem. Is that clear? Let's prove theorem. Let us prove a theorem. Let us prove a theorem. If Z and A are elements in real number with Z plus A equals to 0, then Z equals to 0. Okay? Okay? Okay, let's theorem 1. Amen. Theorem 1. Theorem 1. If Z and A, amen, are elements in real number with Z plus A equals to A, then Z is equals to what? 0. Take note of this, amen. Look at the board very well, please. We want to prove this. We want to prove this. We want to prove this. We will use addition properties here. Is that clear? We use addition property here. That is what we are going to use, and it's simple as ABC. Okay. Proof. Proof. Suppose that we are going to use addition properties. The variable in between them is what? Addition. Suppose that we have Z plus A equals to what? A. Then they said then Z is equals to what? 0. So this implies that our Z plus A is equals to Z plus 0. Yeah. Then this will be equals to. Then they said Z is equals to 0. You can now see that here existence of what? 0 element has come in. True or false? Yeah. Because we want to try to show that Z plus A is equals to A. So if Z plus 0, Z plus A equals to Z plus 0, it means we have introduced what? Existence of 0 law. Then, how can we show that there will be 0 here? So we now move further to write that Z plus Z plus open brackets minus A plus A. Can you see now? Here, look at it here. Here, look at it. You can now see that this is the same thing as 0, true or false. So here, we are able to introduce what? Existence of what? Negative properties, true or false. Then we now move further to write that our Z plus A plus open bracket minus A, this is equals to minus A plus A, which is equals to what? 0. So can you see now? So this is is what you are going to show. You see how simple it is. This is one of the theory. So whenever you come across something of this form, mind you, at first, try to know the operation. But supposing here is multiplication. Is that clear? Will be there. Is that clear? So, since here is what? The operation here is addition. So, you can now see that we use existence of zero law, existence of what? Negative law, true or false. Then, at the end of the day, we finalize. So, gentlemen and ladies, thank you for your time. I love you guys. Please like, subscribe, and share. I'll be very grateful. We'll call it a day. I wish you a wonderful bed rest. Thank you and God bless you. Bye. Love you guys. Please don't forget to share on your platform. Thank you.